Afternoon, my name is Jason Flowers from Tisski, and today we'll be going through a demonstration of Azure machine learning, and specifically a sample that allows flight delays to be predicted based on historical data in relation to weather. So jumping straight in, what you'll see on the screen is a sample for a very simple sample for a user where they can actually choose an airport or a journey that they're taking, time, date and carrier, and they can actually select to predict any delay that might occur based on those geographic locations and the time they're taking it. So as you can see, the weather forecast comes from an external service called Weather Underground, and in this scenario there is no delay predicted. So you can imagine that this service could be extended so that if there was a delay predicted, then as a type of concierge service, alternative routes could be suggested to the end user. But we're not really going to concentrate on the end user interface today. We're going to have a look at the actual underlying Azure technologies that are used to build this application. So diving straight into the Microsoft Azure portal, what we're looking at here is essentially most of the building blocks of this solution. It should be noted that this is a no-code solution. Apart from that very light front end there is no code driving this in relation to C#, .NET or any code such as that. This solution is really made up of composing existing building blocks from Microsoft Azure with a small amount of configuration and using visual designers. So looking at these building blocks on the screen, the most important ones are the first one, which is the actual virtual machine I'm doing this demo from. And as well as being a demo machine, it also represents an on-premise environment which hosts some data for a later demonstration. And the third one in that list, which is actually the machine learning workspace, which contains the experiments in relation to predicting any flight delays, where most of the intelligent work is actually going on. So we're going to drop into the trainee experiment for this solution. And this is a simple example. This interface is a drag and drop interface that allows a user who isn't a hardcore data scientist in order to compose quite a complex solution and leveraging the machine learning capabilities of Azure. So at the top we can actually see that there's two data sets we have here. One is flight delays in relation to airports. These are both historical data sets. And the right hand side one being the weather at airports over time. Now, one great thing for building these within Azure Machine Learning Studio is it is visual, but also the amount of visuals you get allow you to determine what your next move will be in relation to creating an experiment. So at any point we can actually visualize this data set. So what we're looking at here is the raw data set with nearly 3 million rows of data within 20 columns, and we can actually drill down and have a look at these columns and see if there's how many got missing values, how many unique values, and what the distribution of these values over this column are. And we can use this information to determine what our potential next activity or transformation we want to make on this data set. Now in this example we actually run what they call an R script, and R is a scripting language which I won't go into detail here, but just to show you that this isn't significantly complex, then I'm just going to open this R script and there's essentially 5 commands, and the fourth one is of interest, which really is just truncating this data set to include those columns that we actually want the model to use as part of its prediction. So the actual airport, the origin airport, the destination airport, the time and date, and the carrier that's used. They're really the parts of that large data set we're interested in. So once that script runs, we can visualize at any point. So if I visualize this output data set, we can see it's actually the same one, but with the columns truncated to those I asked for. Okay, so the next move, what we do in this experiment is actually join the data, because we've got 2 separate data sets, and what we actually want is we want a data set that contains a specific instance of a delay or a non-delayed airport airplane flight with the associated weather metrics in order to provide to the model so it can actually try to predict weather. So this join, we can see the first set of columns, which are the columns from the first data set, and then we can see the last three with wind speed, sea level pressure and hourly precipitation, which come from the second set of data. So moving on, what we actually do is we split the data, and on the right hand side you'll see that the fraction that we actually split against is 0.7, representing 70%. So this one data set is split into two data sets, one of 70% of the rows and one of 30% of the rows. And the reason why we do this is we actually train the model or experiment using 70% of the data, and then in order to determine the accuracy of that, we use that 30%, and we use the model that's just been trained to predict what if there was any delays on the remaining 30%, and then we can compare those predictions against the actuals within that 30%, and therefore we can score and evaluate the model to determine essentially its accuracy. Looking at the algorithms actually used here, this is two-class logistic regression algorithm. That is a drag and drop from the left-hand side out of a library of machine learning algorithms that are possible. It hasn't taken me as a non-data scientist to utilize that, and again, coming back to the visuals, what it actually allows me to do is to choose one type of model and then evaluate it and visualize how accurate it actually was. So from this evaluate activity, I can actually see that it's 80% accurate, which means over those 3 million rows, this model would predict the correct prediction 80% of the time, which could be improved by either increasing the data set or tweaking the model and changing thresholds. But it allows you to immediately visualize the accuracy of that data set and then refine it over time and potentially remove that regression algorithm and replace it with another one and then visualize it to see if that has made a difference. But anyway, that is the extent of this machine learning experiment, the training experiment. And then after this, what we actually want to do is want to publish it to a web service. So Learning Studio allows us to do that with a few clicks. What it actually does is from this we actually create a predictive web service. So in turn, what that does is it creates a predictive experiment, which, if I just select this now, is pretty much exactly the same as the actual training experiment with a few key changes. Obviously, at this stage there is a web service input and a web service output, because I want the web service for me to be able to give the origin and destination airports and the carrier and the time and date, and I want it to tell me if it predicts a delay or not based on a weather. But another key thing is actually that we're actually using the trained model here. We are not training a model and scoring it each and every time this web service is called. We are using the predefined trained model in order to predict the delay based on the conditions that are provided to it. And if you look down the bottom right hand screen, it's very easy with a couple of clicks to deploy this web service or redeploy it if you've retrained the model directly as a machine learning web service, which is essentially a web service hosted in Azure again, so you get all the scalability and resilience and manageability that you would do with any web service hosted in Azure. But again, there is no code. This is a no-code solution, a little bit of scripting, and we actually have hosted, externally available, secured web service available that predicts the weather without any code. So obviously that's great, and that can be consumed by our end user interface. But over time we are going to be generating more data, and at the moment these are static data sets. And obviously we want to retrain our model for two reasons. One, because if we've got more data, we theoretically should be able to get more accurate. But also, things might change over time. In this scenario, it might be that particular airports get better in poor weather conditions in actually minimizing flight delays. But certainly criteria would change over time. So we want to refresh the data set on a scheduled basis if real time isn't appropriate. So what I'm just going to move over to now is another Azure service called Data Factory, and Data Factory essentially allows is all about taking data from one source, running a series of activities through a pipeline, and then potentially outputting it into another source. So what we're looking at here is a very simple example. Again, this is a no-code solution, and we are using the Data Factory gateway in order to actually reach down into the file system of essentially this VM that has information, a CSV in this case, information in relation to flights. And this is very much intended to replicate the environment where you've got a hybrid cloud environment. So you've got some on-premise data and you're trying to utilize cloud services, and you want to be able to seamlessly pull data up and push data back down. So Data Management Gateway sits on premise and exposes your data sources to cloud services in a secure way, so that they can be consumed by cloud services. So on the left hand side we can see the gateway itself, that is an installation. We can see the data sets, and this is essentially the input data set that comes from Azure Blob Storage, and a scored data set with the activity, and this is the actual work we're wanting to do here, the activity that actually calls the machine learning web service on that data set to create and generate the scored data set. So if I go into these linked services, we've got one input service that is the on-premise CSV file that is uploaded to Azure Blob Storage. We have the output service that is Azure Blob Storage again, and will be used to save the scored data set once the data is pushed through our earlier training experiment. Predictive experiment. And probably the most important one here is the Azure Machine Learning Link Service. Now this, if you look at the right hand side, again, no code solution. This is the declarative JSON that is just describing the service that we actually created earlier, or looked at earlier. And the most specific, or the most salient key on here is actually the endpoint. So that is the web service URL for the web service that we actually promoted through Machine Learning Studio. So again, no code solution, but this is reaching to an on-premise data store. It is pulling the data into Azure Blob Storage. It's running it through the machine learning algorithm that we created, we saw earlier, and then it's outputting the result set into Blob Storage. And once it's into Blob Storage, we have many options of how we might want to consume it. One of those options being Power BI, desktop, mobile, or dashboard, where you might want to dig into, let's have a look at the most offending airports and see why, and just visualize or spin or use the data in other ways. So this was just an overview of how what is a simple interface, but quite a complex solution can be achieved very easily by composing the building blocks of the modern Azure capabilities, which includes things like machine learning and BI intelligence, and transforming data from on-premise to off-premise cloud services with no code, with a few scripts and a few declarative functions. And I hope it was useful. Thank you.